sphere itself. Okay, now Earth's sphere is thought to be composed of 4 layers. Okay, let's see it here. And that's basically what we're talking about here, of course, from the core to the mantle and to the crust. These are the ones we are talking about. Okay, now I mentioned to you here that it's thought composed of 4 layers, which is basically the core, mantle, lithosphere, and crust. And basically all this, as you can see, arranged concentric layers like an onion. Arranged, concentric layer, like an onion. So other way also, it's like this one here. We're going to talk about a little bit here. If you can see this one. So basically that is, and we're going to talk a little bit about each one here. Now the Earth's massive core. The Earth's massive core has a diameter of about 3,500 kilometers. A kilometer, and is made up mostly of hot molten metals. Of hot molten metals, particularly iron. And nickel. And also to mention, basically, of course, inside the Earth, as you know, it's heat. So to mention about this one here, now the internal heat of Earth this is the internal heat, of Earth, is generated by the slow, radioactive decay of unstable isotopes of elements such as uranium. Okay. This is basically we talk about what you call the core. Now we're going to talk about basically about a little bit about the mantle here. Okay. Now, to mention, the mantle is a less dense region. Mentioned to you here. The mantle is a less dense region. Okay. Enclosing. Okay. The core. Enclosing the core. Okay. And basically it has about dimension, about the thickness of this, about 2,800 kilometer thick. Kilometer thick, and composed of minerals okay, in a plastic semi-liquid state of minerals, we call it in a plastic, okay, semi-liquid state. Okay. State. And this is basically this one, what you call that, the mineral of semi-liquid state is basically known as magma. Okay, this is known as magma. And also to mention, and the mantle contain large amount contains a large amount of relatively light element. Large amount of relatively light elements for example, notably silicon, oxygen, and magnesium. And magnesium, of course, occurring in the occurring as various mineral occurring as various minerals, or sorry, mineral compounds. Now the magma from the upper surface from the upper surface or basically that means the upper surface of the mantle sometimes erupt, sometimes erupts, okay, to the surface, okay. And to mention, of course, as volcanoes. As volcanoes, and is, of course, usually, okay, called spewed, okay, to the surface, as already you know, which is known as what you call as lava, okay, which cools, of course, in this case, and when the lava is cooled, become what called ballistic rocks, which cools, okay, what is known as to ballistic rocks, okay. Now, of course, as you already see, basically, we talk about the core, and then we talk about the mantle. Did you follow that here? Now, of course, we're going to talk about basically what you call the lithosphere, which is more or less consisting like the crust and the upper, what we call most solid mantle, this one here. Now, we're going to talk about what you call the lithosphere. Okay. Now, sorry to mention this one here. Of course, okay. The next layer, the lithosphere, I'm going to mention here. The lithosphere basically is only about 80 kilometers thick, something like that. Okay, 80 kilometer thick. Okay, and to basically, and is made, as you can see here, of rigid, okay, relatively light rocks, okay, okay, light rocks, especially, okay, ballistic, okay, granites, or granitic here, okay, and sedimentary one. Okay, and sedimentary ones. Now, usually mention, of course, that these rocks okay, these rocks contain okay elements okay contain elements okay found in the mantle. Okay, found in the mantle, as well as enriched quantities, as well as enriched, continue here, okay, the quantities, okay, of aluminium, sorry, of aluminium, carbon. Anyway, I'm going to continue here. I don't know if you can see it here. Of aluminium, carbon, okay, calcium, okay, potassium, okay, sodium, okay, sulfur, okay, and other lighter element. I'm going to continue here, just to make sure that you can see it here. Okay, do you see that? Contain basically aluminium, carbon, calcium, potassium, sodium, sulfur, and other. Going to continue here, just sometime, just okay, and other lighter, okay, lighter elements. Okay. Now this is basically talk about the lithosphere. Of course, the outer layer or the outermost layer which is known as the crust. Okay, which is basically in reality is this one here. Okay, as you can see it one. So we're going to talk about this one now here. Now, the outermost layer is known as the crust. Is known as the crust. Okay. And of course, what you call in case of the ocean, an oceanic crust. Okay. Is relatively thin. The oceanic crust is relatively thin. I guess you finished from this one here. Okay, just going to put here. Okay. Oceanic crust is relatively thin, averaging about 10 to 15 kilometer thick. Okay. Now, while the continental crust continental crust is about, okay, 20 to 60 kilometer thick. And simply we're going to talk about here, basically the Earth crust is a very, what you call, is very complex. To mention this point here, Earth's crust okay, has an extremely okay, complex mineralogical composition, has extremely complex, okay, mineralogical composition. Okay. Now I'm going to talk about the composition of basically some of the element which constitute what you call this crust here. Now, the most abundant element in the crust, I'm going to talk about here, the most abundant elements in the crust, okay, are, I think I'm going to put it down here so that make it more easier, I guess, to see here, okay. We have oxygen, sorry, about 45%, okay, silicon, about 27%, aluminium, okay, about 8%, down like this, okay. Then we have iron, okay, about 5.8%, okay, calcium, which is about 5.1%. Then we have magnesium, okay, which is about 2.8%. Then we have sodium, which is about 2.3%. Okay, potassium, which is about 1.7%. Okay, and then we have what is known as titanium, okay, titanium, which is about 0.86%, 0.86%, okay. Then we have an element known as vanadium, okay, which are about 0.17%. Okay, then we have hydrogen, which is about 0.14%, sorry, 10%. Phosphorus, which is about 0.10%. Okay, and we have finally and carbon, okay, which is about 0.032%. Okay. Now, as already you know, basically about the the Earth itself, we have about 30% surface and about 70% water. Going to mention this point here. Now, talk about this one point here. Okay, about 30% of Earth's surface surface is covered, as already you know that, by the solid substrates okay, by the solid substrate of continents and islands. Okay, and as you know, the other 70% of is liquid. The other 70%, of course, of the Earth's surface okay, is liquid water, which is most of it basically is oceanic. Of course, there are other. And to mention this point here, virtually, okay, all of which simply to mention is oceanic. Okay. Of course, don't forget, of course, that we have basically the Earth, basically the surface is all immersed in that what you call, in the dense sphere, which we call it the atmosphere. Okay, just okay, which is this one here. This is, you know, just to that basically this is the Earth. So basically, all that we talk about all this, but all that we call it the atmosphere. Okay, to mention this point here. In addition, Earth's dense sphere okay. In addition, Earth's dense okay sphere is immersed okay, is immersed in a gaseous envelope okay, known as the atmosphere. Sorry. Okay. Known as the atmosphere, which basically it could extend to about 1,000 kilometers, which extends okay to a distance of about 1,000 kilometers. Just to mention this point also basically about what you call the atmosphere, to mention this point, however, about 99%, okay, about 99% of the mass of the atmosphere okay, of the mass of the atmosphere, occur within 30 kilometers of the planet's surface. Occurs within, okay, 3 kilometer of, we call it, of the planet's surface. Okay. So basically, by this we describe more or less what you call the Earth and its atmosphere and so on in a very summarized way. Now, of course, to talk about a little bit about what you call geological dynamics. Subtitle here. Okay. Called okay, the geological dynamics. We talk about this one a little bit here. As already you know, basically what, of course, throughout its history, okay, history, Earth has been subject of course, to enormous geological forces. To enormous we call geological forces, okay, that have greatly okay, just make sure that you can see this one here. Okay. It's okay now. That have greatly, as a matter of fact, affected the mineralogical composition, have greatly affected, okay, it's, we call it mineralogical okay, mineralogical composition. Composition and also and surface features and surface features, okay. And to talk about, of course, as you know, these what you call about some of these forces, of course, the predominant influences which is known as are what you call as tectonic forces. Known as the tectonic forces. And basically these tectonic forces, of course, as you know, usually associated what you call with the movement of the crust. And to mention this point here, okay, which are associated okay, which are associated, okay, with the crustal movements. With the crustal movements and other processes okay, and other processes okay, that cause known as what we call a structural deformation of rocks, that cause structural, okay, deformations, okay, of rocks, okay, and minerals, okay, and minerals. Plus to that, of course, as you know, these associated with the continental movement and so on. And to mention this point here, now, geological forces also cause okay, also cause the continents and their underlying plates and they're called under, I'm going to continue called underlying plates, okay, to slowly move as already you know what you call about Earth surface. Okay. Before that, just give me a second here, just to put it down here. Okay. To continue after that, basically, of course, as you know, all that as a result of what you call earthquakes. To mention this point here, earthquakes and volcanoes okay, are also, you finish on this one now? Okay, I will put it down here. Okay, and to make this point, basically that earthquakes and volcanoes, okay, are also what you call tectonic phenomenon. We call tectonic phenomenon, influencing okay, influencing Earth's crust, okay, Earth's crust and surface, this is and, okay, and surface with extremely powerful, okay, with extremely, okay, and surface with extremely powerful, okay, and sometimes disastrous events. What you call a very disastrous type of earthquakes and volcanoes which occurred with the recorded history, as a matter of fact. Talk about this one here, going to mention about this one here. Okay, now, for example, just a small subtitle here if you want to put it down. Example on earthquakes and or volcanoes. Earthquakes or volcanoes. Okay. Now, what are we going to mention here? For example, in 1556, an earthquake okay, an earthquake, as a matter of, struck Shanxi province. Struck, what you call here, this is in China, province in China, okay, and caused about okay 830,000 deaths, okay, making it okay the most deadly okay earthquake, simply to mention, of course, in the recorded history. Okay. Other one also, to mention other example here, other 20th centuries. Okay. Earthquake. Okay. Resulted. Okay. Any great losses. Of, this is ES, losses of human lives. Okay. Including, of course, including one in 1975. Sorry. That killed, okay, about, okay, 242,000 people. This also occur in what you call in China, an area known Dagestan. Sorry. China. We have one of the recent one, which is occurred almost in 2005. We have basically other recent one. Okay, in 2005, which killed around about 79,000 people. that basically occur in Kashmir, which is basically in Pakistan. Okay. Of course, the history also, we have the one basically, we're going to talk about example here. And for example, we have it called the volcanic eruption. Sorry. Eruption of, what's known, of Mount Vesuvius. That occurred basically at the beginning, about 79 of the current, okay? In the year 79, which is this is after the Christ here, okay? Buried this, basically this one is buried, what is known, the whole, buried the Roman, okay, city, maybe you hear that in the history of Pompeii. Okay, killing most of its inhabitants. Of its inhabitants.
Excuse me, sir. What was the name of that mountain or the volcano of Mount what?
Called, oh, sorry, forget that. Oh, sorry, of Mount, I put it down here. Can you see that? Okay, yes. Of Mount Vesuvius, I put it down, sorry. Thanks for reminding me. Can you read it? Called yes. Vesuvius. Okay, that's basically, that's the mountain. Sorry about that. Thank you. Okay, killing most of its inhabitants. Okay. And also we have another one here just to give, because of course this is when we talk about killing of the people, but at the same time, of course, destroying everything of that environment and everything. Okay. Now also we have, for example, in 1902, 1902, this one here, explosion of Montpellier. Okay, of Montpellier. This occurred in the Caribbean island. Okay. Caribbean island of called Martinique. Okay. Also killed around 30,000 people. And also we have one which is very, what you call, very well known in the history, is the one of also occurred in 1883, which occurred in one of the island in Indonesia. Okay, and to mention this one here, just to give you an example, another example here, another famous Indonesian eruption. because basically that earthquake also cause what you call cause also a kind of tsunami. Okay, to mention an eruption. And in that one, basically, what happened here, I'm going to mention it later on, just give me a second here, eruption, was that of this, of called Karakuto. Okay. Basically known as Sonda Strait. And Strait, okay. Basically, we just talk about Indonesia. That occurred about in 1883, okay. Which basically this one here, sometime they have a lot of picture of it, okay, just an imagination, okay, like this, and also cause a huge tsunami of the sea to come covering that area. But what happened here, because in that kind of this event wiped all the vegetation and all the plant, okay, and that also gives later on a lot of basically of this plant geographer to study when they start plant coming and invading the area, and because it happened like a small island, and that gives them to study what you call as the island biogeography and so on, and how basically the plant and animal how they immigrate. Okay, it gives a lot of that study, but in different we may talk about it maybe later on. So the mention here standard 1983, which ejected okay about 18 okay to 21 cubic kilometers. This is km3 cubic kilometer of material, okay, of material as high as okay almost 50 to 80 kilometer in the atmosphere. Into the atmosphere, okay, and basically that caused later on to tsunami, okay, and causing the 30-meter tsunami, okay, associated okay with this eruption. With this eruption, okay, which killed about also 30,000 people, okay, 30,000 people in coastal villages. Okay. The reason why I mention here of some of these, because really all these geological event, of course, in the end, basically it will shape in one way or other or influence the characters of the Earth. Okay, just to continue after this is just an example here to mention. Now to mention, of course, in the end, of course, and that's why we're going to talk about it, that that's over, we call it over geological time. over geological time, these various physical forces okay, these very physical forces or processes, okay, have profoundly influenced the present character of Earth. Okay. Call this the present, okay, character of Earth. Okay. Of course, in general, to mention this one as general statement, okay, as already you know that, but just to mention it here, thus, for example, that geological forces continues or continue, okay, or continue, okay, continue to have enormous, okay, to have enormous influences of course, on Earth, okay, and its ecosystem. And an ecosystem, of course, of both called over both short and long term time. Over, okay, both. I'm going to continue here. Give me a second. Over both, as I mentioned to you here, short and long term, okay, time scale. Okay. Before that, then of course we're going to talk about other forces also which affect the thing, which is, as already you know, called glaciations. Small subtitle here. Okay. If you finish from this one here, did you finish? Okay, just remove it there. Okay. Now, glaciation basically, as you know, is the advances of the through history, and we're going to go, it has sometimes a huge impact. Okay, talk about this one here. Now, glaciation refer, of course, in general, to make this book glaciation. Okay, it refers okay to an extensive advance, okay, of ice sheets, okay, caused by a period, okay, of extended global cooling, okay, by a period of extended global cooling. Okay, and basically that is what is known as, sometimes known as the Ice Age. Sorry. Sometimes, okay, known as Ice Age, as already we know here. And of course, there have been a number okay, of glacial periods. Okay, during Earth's history. Okay. Now, just to mention a point about something, of course, the most recent glacial period the most recent glacial period, this one is known as, we call Wisconsin, known as Wisconsin, okay, which is basically began about 100,000 years ago, and I think lasted almost basically going to mention you here years ago, okay, and ended about 10,000 years ago. Okay. And we for some reason or how we don't refer to this one as what you call as the last glaciation period, because it seems the last glaciation period has not been occurred so far. To mention this point for you here. Okay. Note that okay, this should not be referred to okay, as the last glaciation, of course, glaciation period. Which is simply to mention, which has not yet happened. Okay. Now, basically, we're going to talk about what you call the impact of the glacier on the Earth and so on. Glaciers are extremely erosive forces, to mention this point here. Glaciers are extremely erosive forces, okay, that crush, okay, score, okay, that crush, score, and excavate. And excavate what you call the underlying terrain. hold the under, and continue here, the underlying terrain, okay, with their massive weight. Okay, with their massive weight, okay. Now, also to mention, of course, the other point here, that also glaciers also move huge quantities of excavated debris. Also to mention that glaciers also, sorry, move, okay, huge quantities of excavated debris. This is X here, okay, of excavated debris, okay, around the landscape. Okay. And of course, going to mention this point, and these solid materials of course, are eventually deposited. Sorry. Are eventually deposited okay, when glaciers melt. This is D here, okay? When glaciers melt, okay? Tumbling from, okay? Okay? From, okay, tumbling from what you call melting ice mass, okay, or of course, or being carried away okay, or being carried away, of course, okay, by running melt water. Okay. Okay, sometimes going to think, well. Because sometime we're going to talk about later on, makes a plane like this, okay? It's all over surface like that here, okay? To mention this a little bit of here, melt water, running melt water, okay? Now, to mention this point here, extensive, okay, extensive deposits, okay, of glacial debris, okay, are common over virtually all of Canada. Okay, all of Canada, okay, as recently as 15,000 years ago. And just to mention to you here, as recently as 15,000 years ago, okay, which is basically at the time mentioned virtually all of Canada, okay, was covered by glaciers. Okay. Now, just a title, I'm going to stop my lecture, but just to continue with you with the next lecture here called Weathering and Erosion. Okay, and I'll continue next lecture. And of course, I sent you an email. I know that some student, but at least today we're going to meet around, I think, 2 p.m. Okay, and basically just try to think of a title. And it's not going to be very long, but at least we'll discuss whatever it is here. And if you have any other question, and already I done with the lecture for today. I hope you followed okay. Any other question, please? Well, since there is no question, I guess. All right. Okay, so I'm going to basically now just to end the lecture, I guess. Okay, and we'll see you shortly. Okay.
Thank you.
You're welcome. Take care.
Thank you.
Bye-bye.
Thank you. Bye.
Bye.